The purpose of the loss function is to compute the quantity that the models should seek in order for it to minimize during the training. There are three types of major categories of loss functions. We will cover them one by one, and that includes the probabilistic losses, regressions losses, and also the hinge loss for maximum margins classifications. In machine learning, the hinge function is a loss function used for training the classifiers, and the hinge function is used for maximum margin classifications, most widely adopted for support vector machine. And in the deep learning, the probabilistic and also regressions models are more widely adopted. So in this course, I will just cover the probabilistic losses and also the regressions losses because they are much more popular in the deep learning. Let's take a look on them one by one. The first one is the probabilistic losses binary cost entropy. Binary cost entropies computes the cost entropies losses between the true labels and the predicted label. It is recommended to use these cost entropy functions for binary 0 or 1 classifications problems. And the loss functions requires the following inputs that includes the true labels and also for the predicted value. If the predicted values has a value between negative infinity to positive infinities, that means this is a logit. In that case, we need to set the from logit equals to true. On the other hand, if the value is between the value from 0 to 1, that is a probability, then we need to set the from logit to false. It's always recommended to apply from logit equals to true, especially when you do not have a functions, activation functions at the output layer. The second probabilistic loss, that is the categorical cost entropy and also sparse categorical cost entropy. And it depends on how the labels are encoded in order for us to use these two types of cost entropy. And it is recommended to use these cost entropy functions for 2 or more classes classifications problems. In the first case, we just need to have a binary classifications problems, then we use the binary cost entropy. And then in this case, if we have 2 or more classes classification problems, then we need to use these either one of the probabilistic loss functions. Both loss functions compute the categorical cost entropy. However, the only difference is how the labels are encoded. For one-hot representations, categorical cost entropy can be used. And then for the labels as integers, that is just like 0, 1, 2, sparse categorical cost entropy can be used. And this is the examples of the one-hot label, and this is the examples of the integer label. Say, for example, if we assume there are 3 classes, and then we have 3 lists for the one-hot label, and 100 means that we have the first class, and then 010, and that means we have the second class, and then 001 that represent the last class. On the other hand, for the sparse categorical cost entropy, that is an integer label, and 0 represent the first class, and 1 represent the second class, and 2 represent the last class. So it depends on how the labels are encoded to determine which probabilistic loss functions that we should use. And then we have 3 commonly used regressions losses. That is the mean squared error, mean absolute error, and also the MAPE, that is the mean absolute percentage error. Mean squared error computes the means of the squares of error between the true labels and predicted label. And then we just take its squares and then also take the mean of the summed up value. It's recommended to use these functions for regressions problems, and this is the loss function on one of the sample. And for the MAE, that is computes the means of absolute difference between the true labels and the predicted labels. And the loss function is like this. MAE is very often applied in the matrix rather than the loss functions. If applied, it's mainly used for the regressions problems as well. And then for the last one, that is the MAPE. MAPE computes the mean absolute percentage error between the true labels and the predicted label. And then MAPE is also very often used in the matrix rather than the loss functions. And again, if applied, it's mainly used for the regressions problems. Therefore, mean square error is always the preferable options in many cases. The output layers activation functions will give you the output value, and the loss functions will evaluate the loss value between the output value and also between the true value. Therefore, it's always important to combine the output values, activation functions, and loss functions according to the problem types. Say, for example, if we have the classifications problems, we have the binary output, and then in the output layers, that is the activation function, that is we have the sigmoid functions, then in that case, we need to use the binary cost entropy. However, on the other hand, if we have a single label, multiple classes, in that case, the output layers is the softmax activation functions. We need to use the categorical cost entropy. And for the other cases, is the multiple labels, multiple classes. And because the activation functions that we are using is a sigmoid function, in that case, the loss functions has to be used for the binary cost entropy. And we cannot use the categorical and cost entropy here. For regressions problems, because the output values normally are could be between 0 to 1 or beyond that values. In that case, if the output type is between numerical value between 0 to 1, and then we can, and then if the output layer is a activation functions, there are two choices on the loss functions. That could be MSE or binary cost entropy. And for regressions, if that values is go beyond 0 to 1, and then if that is a numerical value, the output layer by default we will use the linear activation functions. And then in that case, we probably will use the MSE loss function.